Today we're going to start talking about trig for the first time. We're going to do that by looking at different points on the coordinate plane, on the xy plane. So if you're taking notes on a separate sheet of paper, make sure that you're labeling this as trig functions notes day 1. And we're going to go over a couple tidbits of review before we get into the meat of the content. So when you are drawing your triangles today and evaluating all your trig functions, you're going to be drawing a triangle in one of the 4 quadrants of the coordinate plane. The quadrant that we will land in will depend upon the point that is given to us. The key thing that I want you to remember at this top part is that the triangle that's formed is always formed with the x-axis. It can be in any quadrant, but it is always formed with the x-axis. And it is always a right triangle that is formed. So you're going to end up drawing something that looks like kind of like a butterfly here. When they're asking you to find the sine, cosine, or tangent of an angle, the angle is always the angle that is formed with the x-axis. So it's always the angle formed with the x-axis. In other words, it is not ever, your triangles that you form in the coordinate plane are never going to look like this. Yuck. You can like draw your own. Bleh. That is not what we do. So that, I'm going to put a big red X through it, is wrong. It's always formed with the x-axis. Now, back in the spring, you left off just touching on what these 6 trig functions were. So we're going to review those in this space. You've touched on these in geometry as well, and the little acronym that we use to help remind ourselves of the 6 trig functions is SOH CAH-TOA. SOH CAH-TOA is a little abbreviation to help us remember each of those 6 trig functions. Starting off with sine. This S stands for the trig function sine. The sine of an angle just compares the opposite side of the angle to the hypotenuse. So it's abbreviated O over H. That's where that O comes from. Cosine of an angle compares the adjacent side to the hypotenuse. And last but not least, if you're finding the tangent, is the opposite side of the angle compared to the adjacent. So this is all if you have triangle, where you have theta. This would be the opposite side. This would be the adjacent. This would be the hypotenuse. So the sine of an angle compares the opposite to the hypotenuse side lengths. The cosine of an angle compares the adjacent to the hypotenuse. And the tangent compares the opposite side of the angle to the adjacent side. These are all fractions just written as ratios. Now, each of these trig functions has a reciprocal buddy. The reciprocal of sine is cosecant. We abbreviate it CSC. When I say reciprocal, all that means is we're going to take the original fraction and flip it. So it's the hypotenuse over the opposite. Cosine's reciprocal is called secant, S-E-C. The secant is just the hypotenuse over the adjacent. And last but not least, tangent's reciprocal is called cotangent. We abbreviate it C-O-T. It is the adjacent side over the opposite. So again, remember SOH CAH-TOA. That helps you remember your three original trig functions. Sine is the opposite over the hypotenuse. Cosine is the adjacent side of the triangle over the hypotenuse. And tangent is the opposite over the adjacent. We're going to try to write some trig ratios with our the problems that come up when we're given a point that's on a coordinate plane. So let's check this out. We're given a point on the terminal side of theta. Find the value of the 6 trig functions. The 6 trig functions are what we just talked about above. So the first thing you're going to need to do is you're going to need to plot this point that is given to us. 2, negative 2. So we start at the origin, and we're going to go right 2 units. Then we're going to go down 2 units, and we land right here. This side length, where we went side to side, is 2, and we went down negative 2. We're then going to form a right triangle with the origin connected to this point where we landed. Notice how the triangle that I formed with which axis? Hopefully you're thinking the x-axis. It's always going to form with the x-axis. The angle that we're going to be referencing our trig functions from is this angle that's snug close to the x-axis. That's our theta. Now, we only have 2 sides of this right triangle. So the first thing you're going to need to do is find the missing side of that right triangle. We have 2 sides. Hopefully you can figure out how to find the third. If it's a right triangle, we're going to use the Pythagorean theorem. So let's go ahead and do that. We have leg squared plus leg squared equals the hypotenuse squared. So we have 4 plus 4 equals x squared. Take your square root, and you'll need to simplify that. If you think about 8, it breaks down into 4 times 2. So our missing side is 2 square root 2. So always find the third side of the triangle using the Pythagorean theorem with these problems. Now we're going to evaluate to find the 6 trig functions. So we first have sine, then we're going to find the cosine, and then last we're going to find the tangent. We will also find the reciprocals, but we're going to start with these first. Remember SOHCAHTOA. And I would go back to your triangle and label it. So it's all in regards to this theta. Opposite of theta means on the other side of theta. So I'm going to put a little O next to the negative 2. The adjacent side means the side, the leg that is next to theta. So that is our positive 2. And the hypotenuse is, of course, across from the 90-degree angle. If you label your triangle, it makes it much easier to fill in your sine, cosine, and tangent. So sine is opposite over hypotenuse. Find your O length, negative 2. Find your hypotenuse, 2 root 2, and write it as a ratio. Now, the only thing we have to do here is simplify. So we have negative 2 divided by 2. That's negative 1 over the square root of 2. And then we need to rationalize. So we get root 2. Rationalizing means that you get the radical out of the denominator. So we're going to multiply by square root of 2 over square root of 2. We get negative root 2 over 2 would be our final answer for the sine of that angle. Cosine is the adjacent side of the triangle compared to the hypotenuse. The adjacent side is 2. The hypotenuse is 2 root 2. Again, we can simplify that to 1 over the square root of 2, but you need to rationalize by multiplying by the radical that's in the denominator to get the radical out from underneath the denominator, and you get root 2 over 2. The tangent, our last trig ratio, our last basic trig ratio, is the opposite over the adjacent. Look at your triangle, find the O, the opposite is negative 2, and the adjacent is positive 2. Simplify to get negative 1. Pause the screen and rewind if you were confused about any of those 3 basic trig ratios. The last thing we're going to do are the reciprocals. The reciprocal of sine is the cosecant. the hypotenuse over the opposite. So I am just actually going to go back to where I had originally written it and just flip that over. So the hypotenuse is 2 root 2. The opposite is negative 2. 2 divided by negative 2 is negative 1, so you get negative square root of 2 for the cosecant. The secant is the hypotenuse over the adjacent. So the hypotenuse is 2 root 2. The adjacent's 2. 2 divided by 2 is 1, so you just get square root of 2. And your final reciprocal trig function is cotangent. We abbreviate it COT. It's the adjacent over the opposite. Adjacent side is 2. Opposite side is negative 2. So you get negative 1. We're going to do a few more of those examples, but rewatch if you're confused by anything there. We're going to keep on doing the same thing with these next few problems. Again, you're going to want to first plot your point. Start at the origin. We're going left 3. So this side length is negative 3. We're going up 4. Remember that your triangle that's formed is always formed with the x-axis. Okay. Theta is always this angle that's right here. And you'll remember from the page before that in order to find the hypotenuse, we have to do the Pythagorean theorem. You might have been able to recognize that this was a 3, 4, 5 triangle, and it would save you time when you're doing your Pythagorean theorem. So we start out, we're going to find the sine, we're going to find the cosine, and we're also going to find the tangent. If it helps you, at the top of your paper, go ahead and write so, ka, toa. Take a second and go back to that triangle and label your opposite, your hypotenuse, and your adjacent. Hypotenuse is the easiest to label, across from the 90. The opposite is in regards to this angle that's snug close to the x-axis, so on the other side of the x-axis. And then the adjacent side is the leg, always the x value. Okay, let's try filling in. Sine, you'll remember, is the opposite over the hypotenuse. Opposite is 4, hypotenuse is 5. No rationalizing needed. Let's go ahead and do the cosecant. It's just that fraction flipped over, so we get 5 over 4. The cosine is the adjacent side of the triangle compared to the hypotenuse. The adjacent side is negative 3. The hypotenuse is 5. The secant would be the reciprocal of that. Hypotenuse over adjacent, so it is negative 5/3. And last, the tangent is the opposite over the adjacent. Opposite is 4, adjacent's negative 3. You can keep it as an improper fraction. The reciprocal of tangent is the cotangent. Flip that fraction over. You can see it moves much quicker when you don't have radicals that you have to rationalize. Pause and rewatch if you had any questions on that problem. This next one's going to be in a different quadrant. Let's still try drawing it out. Well, you always have to draw it out. You always have to draw your triangle. So we have negative 2, negative 1. Drawing your hypotenuse. Remember, theta is always formed with the x-axis. It is never formed with the y-axis, and this is a right triangle. Go ahead and try your Pythagorean theorem to find your missing side. You should get that your hypotenuse is the square root of 5. I would, in this step, also go ahead and label your sides. Your hypotenuse across from the 90. Your opposite is opposite theta. Theta is always the angle formed with the x-axis. and your adjacent is the leg that is right next to theta, or the x value. I would also write SOHCAHTOA up at the top, especially if this stuff is rusty in your brain. And let's get started. We're going to find the sine first. Fill in your opposite side, fill in your hypotenuse. We cannot leave it like that because we have this radical down in the denominator. So rationalize by multiplying by square root of 5 over square root of 5 and multiply straight across. You should get negative root 5 over 5. We'll go ahead and also do the cosecant since we're on sine. Cosecant is the reciprocal of sine, so it's just the fraction flipped over. So you get root 5 over negative 1, which we can just write as negative root 5. Moving on to cosine. The adjacent over the hypotenuse. Should get the adjacent is negative 2. Hypotenuse is square root of 5. We can't leave it like that because we have a radical in the denominator, so you multiply by the square root of 5 over the square root of 5. Your final answer should be negative 2 square root of 5 over 5. Secant is the reciprocal, so flip that fraction over. It's probably easiest to use this initial one, but you can also just go back to your triangle and take the hypotenuse, square root of 5, put it over your adjacent, negative 2. We can keep our answer like that because the radical is in the numerator. Last one, tangent. Let's try it out. Opposite over adjacent. The opposite side is negative 1. Adjacent side is negative 2, so you get 1/2. The cotangent is the reciprocal of 1/2, so just flip that fraction over and you get 2. Pause, rewatch if you have questions. I'd like you to try this last one out on your own. Go ahead and pause the screen and make sure you can plot the point negative 3, 6. Find your missing side, and then find all 6 trig functions. We'll check it in just a second. When finding your missing side, you should have done the Pythagorean theorem, found that the hypotenuse is the square root of 45, which can be simplified to 3 square root 5. When you put that 3 root 5 on the hypotenuse, you can label it with an H. Label your side that is opposite your angle, that's 6 as O, and the x value is the adjacent side. Now try to find all 6 trig functions. For your sine, you should have compared the opposite side to the hypotenuse. The opposite side is 6. The hypotenuse is 3 root 5. 6 divided by 3 can be simplified to 2. You have 2 over root 5. And then in your final step, make sure you're rationalizing. You get 2 root 5 over 5. The cosecant is the reciprocal, hypotenuse over opposite. So you have 3 root 5 over 6. 3/6 can simplify to 1/2, so you just have root 5 over 2. Cosine is the comparison of the adjacent side to the hypotenuse. The adjacent side is negative 3. The hypotenuse is 3 root 5. Negative 3 divided by 3 is negative 1, so you have negative 1 over root 5. Rationalize it out, and you get negative root 5 over 5. Just to be clear, you cannot simplify negative root 5 over 5 any further because that negative root 5, that 5 in the numerator is underneath the radical, so you'd leave it like that. Secant, you should have done the reciprocal of that and gotten negative root 5. And our final one, tangent, let's check that one out. Tangent is the opposite over the adjacent, so you should have 6 over negative 3. 6 divided by negative 3 is negative 2. Cotangent is the reciprocal of that. Flip the fraction over, you get negative 1/2. Pause and rewatch and log into office hours if you're confused by any of this. I would love to answer any questions. Otherwise, start that assignment.